Hello everybody, welcome to AP Physics. This lesson is Vectors 101, and there's a packet that's associated with this. It's on your Moodle course like this video is, and we're just going to kind of go through it. Just so you know, this is the class where 2 plus 2 does not equal 4 all the time, okay? So maybe you already know that. And what I mean by that is when we have vectors, what do we have? We have size. And what else? Okay. Size and direction. Very good. Okay. So when we draw a vector, like if you see v equals v sub naught plus at, some of your books have a little arrow on top of the symbol, which means vector. But in our AP Physics tests and the equation sheets, there's no arrows to signify if something's a vector or not. So you just have to know that. So I'll never do that. I think in math, though, they usually always do that. I don't know. But a vector has size and direction. Now, this is the way we show with picture a vector. Okay, so the size then is the magnitude. So in other words, if this vector is 10, then this vector is 5. So the length of the line is to signify the magnitude. You have to know this for the AP test. And then the direction would be, if we call this a positive direction, then this is a positive direction. If we are in the same problem, by default then, this would be a negative direction. So the positive and the negative of vectors means 180 degrees different from each other. So you might be wondering why they say 2 plus 2 doesn't always equal 4. Well, 2 plus 2 can equal 4. And what I mean by that is, if I have 2 plus 2, that equals 4. Okay, so you understand that. But if I have 2 plus 2, that equals 0. Because you have to consider the direction as well as the size when you're doing vectors. Okay, so really, what do you think the correct answer is for 2 plus 2 equals? I think the best answer from the crowd was 2 plus 2 equals anything from negative 4 to 4. So what I mean is, if I'm going with convention, 2 plus 2 equals 4, positive, right? If I stick with that convention, then by default, 2 plus 2 equals negative 4. Does that make sense? And then the whole, anything in between, well, the easiest one, we already did, 2 plus 2 equals 0. But then what if we go 2 plus 2? Well, that's where it comes from anything between 4 and negative 4. So now what we're doing is we're setting up our vector addition, okay? So vector addition is easy if everything's in a straight line. It's just plus and minus. If it's not in a straight line, then what you need to do is right angle trigonometry. Okay, so toa. Okay, so if you don't remember what this means, it's sine theta is equal to the opposite over the hypotenuse. Okay, cosine theta is equal to adjacent over hypotenuse. And tangent theta is equal to opposite over adjacent. And these are all talking about the different legs of a right triangle. Okay? So if you're not sure or you forget what those legs are labeled, well, the long one's always the hypotenuse. So in this case, this is hypotenuse. If I'm talking about having the value of that angle, then the opposite number then is opposite of the angle, which becomes that side. So this would be called opposite. And then adjacent is right next to. Okay? Now, can opposite and adjacent be switched? Yeah. If I am, hypotenuse is always hypotenuse, it's always a long one. But if I'm talking about this angle, then the opposite of that is over here, and the adjacent to that angle is over here. Any questions about that? So, since we all know that, it's really review, we'll just do a couple examples, and then we'll probably just be done with this. So, let's say that we have 5 plus 9, okay? I want you guys to work that out on your computer and tell me what the answer is. Okay, so what you want to do is make sure that your vectors are in right angle form. So 5 plus 9, oh, I better make that one smaller because the length of the line matters, right? And this here then is the resultant, okay? So whenever we add our vectors, we always go head to tail. There's a couple different ways to do this, but the easiest way is going from head to tail. So that means you start at the last head with the next tail. But then, of course, the resultant is the opposite of that. The resultant is always from the very initial position to the final position, okay? So we do head to tail, vector addition, and then we come up with our resultants. Okay, so then you just put in your numbers here. 5, 9, and the way you do this on your calculator then is, in this case, what's that formula? It's Pythagorean theorem. A squared plus b squared equals c squared. Okay, so we can do that, right? So then c is the hypotenuse. It's a square root of 25 plus 81. So c, or r, or in this case our hypotenuse, is equal to, I'll go 25, oops, my calculator, I'll go 25 plus 81 equals, and take the square root of that. Take the square root of that here, and we get, for a resultant then, we get 10.296. 10.296. Now, is that our answer? No. Because this is vector, right? What part of the vector do we have here at this point? Magnitude. We have magnitude. So that's not good enough. Because we need to describe this with an angle. So this is the angle I'm going to use to describe that, because it makes sense. If you're telling somewhere to go, you say, you know, go at a certain degree or angle, and you'll get there. You don't ever say go to where you're supposed to end up, and then look back and you'll be at a certain angle. So you always label the angle from the beginning of the resultant. Okay, so now that I have 3 sides, I can use anything, but I always typically use the 2 that were given, because if I screw up my calculations, I'm going to screw up the angle. So that relationship is opposite and adjacent, right? So we go tangent is equal to opposite over adjacent, or inverse tangent I forgot the theta sign here, but the tangent theta is equal to opposite over adjacent. So inverse tangent then is, it's really telling your calculator to look through a big table of relationships. And the relationships are the ratio of the sides. And if it knows the ratio of the sides that you're talking about, then it'll tell you what angle is associated with that. So like if I have, you know, an angle like this, or a triangle like that, I'm going to have a ratio of this side to this side. Just as if I have a triangle like this, it's going to be the same ratio of that side to this side. Just if I have a triangle like this, it's going to be the same ratio of this side to this side. So as long as your calculator knows the ratio number, which you tell it to find. You say, hey, when you push inverse tangent, you say, I'm going to give you a ratio number. You tell me the angle that's associated with that. Like, when I was in school, we had to look in the tables in the back of the book. Oh, so the inverse tangent then is equal to the opposite over the adjacent. I'm sorry, it's not equal to the opposite of over adjacent. The inverse tangent of the ratio of opposite over adjacent is equal to theta. So how do you do that in your calculator? Well, it depends on your calculator. But in this case, my opposite is 9, my adjacent is 5, so I go 9 divided by 5, and I have that ratio. And now I want to tell the calculator, hey, what angle do I get with this ratio? So then I put in my inverse tangent right here, and it gives me a number. So my angle in this case then should be equal to 60.95 degrees. Okay? So is that my answer? 60.95 degrees. Is that my answer? What is my answer? So far, let me erase some of this stuff here so I can look at this. So far, we have a resultant that is equal to 10.296 at, I'll go like this, what did I say, 60.95 degrees? Is that my answer? Why is that not my answer? Well, because if 60.95 degrees also needs an orientation as well. Right? Because 60.95 degrees from where is the question that we need to answer. So what you do in this case is you put your vector on with the arrow origin on a grid. Okay, so this is something maybe you did do in math, but I'm going to show you the way that we do it here so we all do it similar. Now, if you look at these, this would be the negative y, this would be the positive y, this would be the negative x, and the positive x. Does that make sense? So, if this here is the angle that we named, which in this case it is the angle we named, then we say that it's 60.95 above positive x. Is that my answer? So that is what I expect for any time we have an answer that we need to give in vector form. Okay, one more thing I want to show you here. Okay, if I happen to have 5 plus 6 at 30 degrees, how do I add those two together? Okay, well, here's something that you have to remember. If you're all x's and all y's, you're all good. So if you look at this, is this here all x's or all y's? No, it's a combination of the two, right? So what I want to do then is take and figure out this piece and this piece. So I'm making a right triangle out of a non-right triangle vector, or a non-purely x or purely y vector. So then I can just add up my pieces. So I would do a little bit of trigonometry. So the sine of 30 is equal to opposite over hypotenuse, which you guys know that already, right? So in this case, we're looking for the positive x value, or the positive y value. So sine of 30 is going to be equal to this, whatever the positive y value is, over 6. Okay, so if you put that into your calculator, you'll see that your positive y value is equal to 3. Do you agree with that? Okay, so now we know that we're going to have a positive y value of 3. Now to find this one, this is the positive x value, so it would be the cosine of 30 is equal to the positive x value over 6. So the positive x value then is equal to, so it's 5.196 Okay, so now you take all of these numbers together as one. So you have a new triangle that's 5 and 3 and 5.196. And then finally, this is our resultant. Okay, so you go, C is the square root of 5.196 squared plus 8 squared. Our hypotenuse value then is, I put my numbers in wrong, I'm sorry about that. This here, these are opposite, so this is 3 and this is 5.196, so that changes this too. So it's going to be 10.196 squared plus 9. And what is our hypotenuse then? 10.6. Do you agree on that, everybody? So now we know our actual resultant number is 10.6. Okay, and now we have to do our tangent inverse of opposite over adjacent equals theta. And what is that number? So it's at 16.4 degrees, and that would be above positive x, okay? Okay, are there any questions about vector addition or vectors 101? Okay, so just remember you have to turn everything into x's and y's, and we did addition for both of these, but there's a time when you're going to have to subtract some of your x's too if they're in the opposite direction. Okay, have a good day.